You made this problem for me?
I did, because guess who it involves?
Oh, dear. Oh, my gosh. You know what, though? I'm so excited. I came prepared.
Oh. Okay, after having lunch to work things out, Taylor Swift and Kanye West approach an elevator. The lunch went surprisingly well, but alas, Kanye mouths off at Taylor again. What's the problem? Classic. She's livid. They need to go their separate ways. At the same time, Taylor starts to walk away from the elevator at a rate of 2 feet per second.
Okay.
Kanye starts to go up in the elevator at a rate of 7 feet per second. What rate is the distance between these two frenemies changing 15 seconds later?
Okay. And those 15 seconds could be imperative, to both of their lives.
I mean, exactly. Math is life, people.
Namaste.
Okay, so first of all, would you agree, we've both taught this class many times, would you agree that everybody has a meltdown about these problems?
I mean, nobody's favorite is related rates until, that's our favorite, but.
It's our fave, and for good reason. They're super fun, right? So let's not let this intimidate us, and let's just, without judgment, namaste, continue.
We got this.
Okay, so let's start by drawing a picture because we're creative.
Okay.
So we have an elevator. Beautiful drawing. Would you agree?
Oh, yeah. Your elevator is spectacular.
Thank you. And so Taylor is walking away from the elevator.
Okay.
Walk, walk, walk. Okay. I'm going to call this distance X. Again, this represents Tay-Tay.
Okay.
It doesn't represent Tay-Tay. It represents her distance that she's walking.
From the elevator.
And right. And then let's go up. Kanye is going up here.
Okay.
What variable do you want to use for him?
Y, because why though?
Yeah. And what we're looking for is the rate at which the distance between these two people is changing, which would be the distance between Kanye and Taylor would be this distance right here in orange. Right. And I'm going to call that Z. Okay. Now, after we draw a picture, I think it's good to write down what do we want to find and what do we have.
Mm-hmm.
So first of all, let's go through what we have already. So first of all, it said that Taylor is walking away at a rate of 2 feet per second.
Right.
And we want to write that down in symbols, okay, in the proper notation. So what it's going to be dx dt.
Because X really is a function of time, right?
That's right.
Okay.
That's right. And another way to say this would be the rate at which X is changing with respect to time. That's what dx dt means, okay? And right, so that's equal to 2.
Cool, got it. More time goes by, the further Taylor gets away from this nonsense.
Yes, exactly. Now, what is 7? How do I write that down? What is the proper notation?
Well, that's Kanye's rate or speed of getting away from Taylor. So that's dy dt.
Dy dt, that's correct.
Yeah, the rate of change of y with respect to time.
Exactly. And what we're looking for is dz dt, the rate at which the distance between them is changing with respect to time. And we're looking for that when t is equal to 15 seconds.
I love these because they feel like a little like snapshot moment of real quick, like at this moment, at 15 seconds.
Right, and right, that's what derivatives are all about, right? Is instantaneous rate of change right at that given moment of time.
Got it.
Okay, so now we're going to step back. And before I go on, what I want to say is that with related rates problems, when you're drawing your picture, so when we initially drew this over here, do not label rates. So what I see students doing a lot of the time, and I'm sure that you've seen this too, is like they'll go over here and they'll label this 2 and they'll label this 7. No. Yeah, that's going to mess you up.
Yeah, that makes it look like that's a distance of 2 and a distance of 7, like feet.
Exactly, and it is not that. So that's something really important to keep in mind, because I see that really messing people up. Okay, so now we're going to take a step back and we're going to ask ourselves, how can I relate all of the variables that are on our page? How can I relate the variables X, Y, and Z? So you tell me, Lindsay.
Well, I see a triangle happening here and perpendicular action.
Yep, so this is a right triangle.
Yeah. So our good old friend Pythag comes in.
Yep.
So yeah, Pythagorean theorem. Let's go for it.
Great. Which is that x squared plus y squared is equal to z squared.
Nice.
Nailed it.
Nailed it.
Okay. So now what we're going to do, since, you know, what do we have here? We have dx dt, dy dt, dz dt. We're going to need to take the derivative of this equation with respect to
t.
Yes. So we're taking the derivative of this, of both sides, with respect to t.
Got it.
Just say of this whole thing like this, actually. Okay. So this is implicit differentiation, right? We're taking the derivative with respect to time. This is why notation is so important in these. So derivative with respect to time of x squared is 2x dx dt.
Chain rule.
Chain rule plus 2y dy dt is equal to 2z dz dt.
And that's what we want.
That is what we want. That's what we're trying to find.
Right.
Okay. Now we're hoping, if we're trying to find this little lady right here, that we have everything else in the equation. Okay. So let's go through and plug in what we have so far.
Okay.
So what do I have? I have dx dt. That's equal to 2, right? I have dy dt. That's equal to 7.
Yep.
That's actually all I have, huh?
Right off the bat, yeah.
Right off the bat. So we're going to have to do a little bit more work here, and we're going to have to find x, y, and z. Now, one piece of information we haven't used yet is this t is equal to 15.
Right, that's the little snapshot moment.
Exactly, that's the snapshot moment. So you tell me, at t equals 15, how far has Taylor walked?
Okay, well, I think we're gonna have to, let's see. At 15, I don't know what to do. What do I do?
Okay, well, here's the deal. She's walking she's walking away at a rate of 2 feet per second.
Oh, and we're going 15 seconds.
Yes.
So 15 times 2.
Yes. So she has gone 30 feet. Agreed?
Yeah, actually we're using distance equals rate times time, but like we don't even.
That's exactly right.
Yeah.
Hold on,
it's so like. Oh, go ahead.
Yeah, there we go. So she's gone 30 feet. Agreed?
Totally.
And how far has Kanye gone right at 15 seconds?
7 times 15.
7 times 15, which is blah, 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 105, right?
Yeah, you beat me to it.
Okay, cool. Can you find Z for me?
Yeah, so then Z, if we solve, would be 109.2.
109.2. Okay, perfect. I think we have everything we need to plug in and solve this girl, excuse me. So now I'm going to back to this equation here. So it's 2 times x. What was x again?
Taylor's distance. Oh, 30.
30. And then dx dt is 2. Okay. Plus 2. Y is what?
105 feet.
105. Whoops. 105. And dy dt was 7 is equal to 2. Z is 109.2. And then dz dt, that is what we're trying to find.
Nice. So we have all constants except what we want.
Exactly. Now, we're all adults here. Can I trust you to solve it from here?
Yeah. So
okay.
All those constants, isolate dt, and we get,
wait for it, dz dt is going to be 7.28.
7.28 what?
Exactly. So what units are we going to put on that?
Well, it's feet, but per second.
Exactly. Feet per second. We're talking about a rate, right?
Right.
Per second.
Yeah.
And that's it.
Nailed it.